Good morning students. Welcome to the next lecture of electronic measurements and instrumentation. Up to now we have seen the different types of concepts in the oscilloscopes. In the last classes we have seen the block diagram of CRO, simple CRO, next triggered sweep CRO, triggered pulse, vertical amplifier, horizontal amplifier. Right? The first one block diagram of CRO, second one simple CRO, third one vertical amplifier, fourth one horizontal amplifier, next fifth one triggered sweep CRO, sixth one triggered pulse circuit. So these are the 6 different topics we have seen up to now in the concepts of oscilloscopes. Right? So here for the oscilloscope, we have 2 input channels or maybe 1 input channel. At the input channel side, we are giving some signal by using a CRO probe, and this signal information, the main motto of our oscilloscope is this signal information has to display on the CRT screen. Right. So when it is taking this signal, we have 2 paths, that is vertical direction paths and horizontal direction path. That is, one side of information we are giving to the vertical deflection plates and another side of information of the signal is we are giving to the horizontal deflection plates. Now, in the previous class we have seen what is the components are available in the vertical deflection plates and what are the components are available in the horizontal deflection systems. And we have seen the triggered sweep circuit and triggered pulse circuit. Okay, so coming to here, we have some different circuitry in the horizontal direction and the vertical direction. In the vertical direction, we have one vertical amplifier only, and in the horizontal direction, we have a time-based generator, or a sweep generator, and we have a horizontal amplifier. Then we are giving horizontal deflection plate system. With compared to the vertical direction, horizontal direction we have lot of informations. We have lot of hardware circuit. So coming to here, at the CRT, the horizontal direction information and the vertical direction information, both information has to synchronize and it should display the information on the CRT screen. That means the horizontal information, vertical information has to synchronize here. For synchronization purpose, we are taking one more concept in the vertical direction. Why? Because in the vertical direction we have less components, horizontal direction we have more components. Where horizontal direction has to process the signal for a long time, but vertical direction they will compute the signal within a less time. But if the both signal, see here, the vertical direction, horizontal direction, it is ready to compute the signal in less time. It is going to compute the signal in more time. Okay, but at the end of the CRT, these 2 signals has to be synchronized. If these 2 signals has to be synchronized, the vertical direction signal has to wait up to getting the horizontal direction signal. Okay, for that reason it has to wait. So where the vertical direction system has containing one more circuit that is called delay line. That is today's topic. That is delay line triggered sweep CRO. So today our topic is delay line in triggered sweep CRO. Right? Let us enter into the delay line and triggered sweep circuit both. Okay, see here, this is a waveform. This is the waveform of our CRO. In this CRO waveform, This is called delay line waveform. In the starting place, see here, the sweep period is started here. Before the sweep period, this is the period called we lost the signal because of some of the information. So see here, whenever the hold period is there, after the hold period we have the discharge curve. After discharge curve we have the charging curve. So whenever this charging curve is there, then only the signal has to be displayed. But before that, here the signal is started and some portion of the information we are going to lose. So this much of portion we are going to the signal loss. So see here, the graph indicates the amplitude of the signal with respect to the time and the relative position of the sweep generator output signal. So this is the sweep generator output signal, the amplitude with respect to the time. The diagram shows that when the delay line is not used, the initial part of the signal is lost and only one part of the signal is displayed. So see here, actually the signal has to start here, the signal tracing has to start here, the sweep period has to start here, but the vertical information already started before entering into the horizontal direction information, but that means we are not getting that horizontal information up to now, but the vertical information is going to start the display. Here the sweep period is started. In the time-based generator, the sweep period is started here. That means that actually the time, the received signal time period is started actually here. But the vertical direction information signal already displayed here. So what the system will consider, up to here, the signal will be not taken. So that reason, this part of the signal we are losing. Okay, here we have to provide some delay here. Then the sweep signal, if it is started here, then it's not a big problem. If the signal is coming like this, it's not a big problem. If the signal is started here, then the vertical information and horizontal information both are synchronized. So this much of delay we have to provide. For that reason, we are using the delay line in this triggered sweep CRO. Okay, right. Let us see. So this is the block diagram. This is the block diagram of delay line in triggered sweep CRO. So see here, this is the input signal. This is the pre-amplifier. This is the main amplifier in the vertical amplifier concept. So here, the output of this main amplifier or vertical amplifier, we can give directly to the vertical deflection plates. So here we have VDP1 and VDP2. And here we have HDP1 and here we have HDP2. Here we have vertical deflection plates and horizontal deflection plates. Here we are giving the vertical amplifier output to the vertical deflection plates by using a special circuit called delay line. And here we have a trigger circuit and here we have a sweep generator circuit. For example, whenever the signal is available at the output of the preamplifier, at that time, the time value I am considering is equal to T0. I am considering the time period at the place of vertical amplifier output is T0. So here I am providing the delay of 200 nanoseconds, which is equal to the time which will process the sweep generator and triggering circuit. So this triggered circuit and sweep generator circuit, it will collectively take some time. The time I have represented here. Okay, so this is the sometime. This is the term sometime it is consuming. So nearly it will consume maybe 100 nanoseconds or 120 nanoseconds. And additionally I have providing some time T0 plus 80 nanoseconds. So this is time T0 with 200 nanoseconds. Okay, so this delay line will wait wait up to getting the time-based generator circuit or sweep generator circuited information after getting this information, then only this delay line allows the vertical direction information to the CRT. Then both informations are synchronized here. Finally, it is displays the signal information here. To counteract this disadvantage, the signal is not applied directly to the vertical plates. The signal is not directly applied to the vertical plates, but it is passed through a delay line circuit as shown in this figure. Okay, so this is the main purpose of delay line. So this gives time for sweep to start at the horizontal plates before the signal has reached to the vertical plates. So see here, first here we are giving so horizontal plates and vertical plates both are important. So the vertical plates information we are getting first. For that reason we are giving delay line to the vertical plates. It will wait up to getting the signal from the horizontal plates. Okay, horizontal deflection system. The trigger pulse picks off at a time T0 after signal has passed through the main amplifier. After T0, it will pass through the main amplifier. The sweep generator delivers the sweep to the horizontal amplifier and the sweep starts at HDP. HDP means horizontal deflection plates at time T0 plus 80 nanoseconds. So this is the time period it will take the sweep of information at the horizontal deflection plates. Hence the sweep starts well in time since the signal arrives at the VDP at the time of T0 plus 200 nanoseconds. So the vertical deflection plates are receiving that information after T0 plus 200 nanoseconds. The horizontal deflection plates receives the information after T0 plus 80 nanoseconds of the horizontal direction. So that is about delay line circuit in the triggered sweep CRO. Next, so this is the sync selector for continuous sweep CRO. Sync selector for continuous sweep CRO. This sync selector, so see here we have a sync pulse generator. Here we have a sync pulse generator and the signal we are giving to the continuous sweep CRO, that is to horizontal sweep generator, and this information here we are synchronizing. If you want the internal signal, that may be the channel information, internal vertical amplifier is connected in this direction to the sync pulse generator. Otherwise, if you want from externally connected signal, so the sync pulse generator is synchronizing with the externally connected signal, or otherwise it is connected in the line connected signal. So these are the three parts. So see here we have the input channel information, and this information we are connecting to the vertical amplifier. This vertical amplifier information we are connecting to the time-based generator through the sync pulse generator, time-based generator or sweep generator through the sync pulse generator. So this is the internal signal, internally connected signal to the time-based generator. Otherwise, you can connect the second. Here we have the switch position. The switch has to be connected either internally or externally or line. So these are the three-way switch. This is the three-function switch. The synchronous selector is a three-position switch where internal, external, and line. Three modes of connectivity is available. Therefore, the horizontal sweep can be synchronized with the signals coming from any of the three sources. So the synchronous pulse generator is connected any of these three sources. One is external, second one is internal, third one is line. So this is a sync selector circuit. Next, dual beam CRO. Dual beam CRO. Dual beam CRO. Our next concept is dual beam CRO. This is the block diagram of dual beam CRO. In this block diagram, see carefully, we have two signals, two input signals, that is two channels we can give here. That is first signal A and signal B. So from the signal A, we have preamplifier and attenuator, and signal B we have a preamplifier attenuator. So here channel 1, channel 2, this is the channel 1 and this is the channel 2. Channel 1 and channel 2 both are available. For the channel 1, what are the components are available? For the channel 2 also the same components. So here preamplifier and attenuator is available, delay line is available, main vertical amplifier is available. Preamplifier and attenuator for the signal B, that is channel 2, delay line for channel 2, main vertical amplifier for channel 2. So see here these three components are same for channel 1 and channel 2. But these main amplifiers, where these two main amplifiers are connected. So see here we have VDP1. These are the vertical deflection plates 1 and vertical deflection plates 2. Here we have two more vertical deflection plates, VDP3 and VDP4. Here we have totally 4 vertical deflection plates are there. So first two are the first vertical deflection system that is connected to the first channel main amplifier. So these two vertical deflection plates are connected to the channel 1 signal, and remaining two vertical deflection plates are connected to the channel 2. That means in the dual beam CRO, the CRT has consisting of two sections of vertical deflection plates. Two sections of vertical deflection plates. So this is the first section and this is the second section. And these two are the horizontal deflection plates, where this channel 1 vertical amplifier output and channel 2 vertical amplifier output we are connecting to a trigger circuit. So the first channel I am representing with channel A, and the second channel signal I am representing with channel B. So channel A is one switch, channel B is another switch, and the external is another switch, and line is another switch. Totally 4 channels of information is there. Finally, here the switch is 4-way selector switch. 4-way selector switch. So this is the horizontal direction information, where this connection leads to the horizontal deflection plates. So see here in the horizontal deflection plates, we have trigger circuit, we have a continuous sweep generator, and we have a horizontal amplifier. These three blocks are very, very important in the horizontal deflection system. So in the vertical deflection side, we have amplifiers, delay line, main vertical amplifier. In the horizontal side, so after the preamplifier and attenuator, we have trigger circuit, sweep generator circuit, horizontal amplifier, and finally it is connected to the horizontal deflection plates. So this is the block diagram of dual beam CRO. This is the block diagram of dual beam CRO. Let us see the description of this dual beam CRO. The dual trace oscilloscope. So this is, we are discussing dual beam CRO, but this point is meant for dual trace CRO, that we will discuss in the next concept, in the next video lecture. The dual trace oscilloscope has one cathode ray gun and an electronic switch which switches two signals to a single vertical amplifier. This is about for dual trace CRO. This point is meant for dual trace CRO. This is dual trace CRO. The second point, the dual beam CRO uses two completely separate electron beams. It has two separate electron beams, two sets of VDPs, that is vertical deflection plates, and a single set of HDP. Whether that is one set of horizontal deflection plates and two sets of vertical deflection plates here we are using. Next, only one beam in the dual beam CRO, only one beam can be synchronized at one time, since the sweep is the same for both signals, that is common time base used for both beams. Here for the dual beam CRO, in the dual beam CRO, we have only one time base generator. That means only we have one horizontal deflection system for both signals, but both has two different vertical sections. Therefore, the signals must have the same frequency or must be related harmonically in order to obtain both beams locked in the CRT screen. Here they have same frequency, both signals has same frequency and they are locked at the CRT screen. Example, the input signal of the amplifier can be used in the signal A and the output signal is B. So here, see example, the input signal of the amplifier can be used the signal A and the output signal B. So here, whatever the input signal you are using at the channel B also we can use the same signal. Otherwise, in the channel A we can use input signal for a circuit and the output signal we can connect to the channel B. That means input output of a circuit you can see at a time. Alright. So this is about dual beam CRO. So it's very important. Remember, this dual beam CRO is consisting of two sets of vertical deflection plates and one set of horizontal deflection plates. Here we have channel 1 and channel 2, channel A, channel B, and one only time-based generator circuit. So coming to the review of today's class, in this lecture we have discussed delay line in triggered sweep circuit, sync selector for continuous sweep CRO and dual beam CRO. In the next class we will discuss dual trace CRO. Okay, thank you.